So let's talk about shorthand electron configurations now, which is a way of shortening up how much we have to write down in the end. We sometimes also call these noble gas configurations because it's the way that we're going to shorten it up by writing a noble gas. So let's take a look at an example one. Let's write the shorthand configuration, or let's write the longhand configuration for calcium, which would be there's 20 electrons, so it's 1s2, 2s2, 2p6, 3s2, 3p6, and then don't forget it's one of those weird ones where it goes up to 4s2, so it sort of skips over something don't forget there's a 3d orbital available, but it gets used after the 4s. Now the trick is after a while you might figure out that that's sort of long to write. And so what we do is we look for the noble gas that comes before calcium. And so in this process, let me point out one thing I sometimes see people write down anything as to shorten this up, but really in the end it's only a few elements that you can use to shorten this up: helium, neon, argon, krypton, xenon, or radon. So those are the only things that you can write to shorten up this thing. Now the trick is that you might notice that let me write down argon right here. Argon's configuration is 1s2, 2s2, 2p6, 3s2, 3p6, because it only has 18 electrons. And so what you might notice is that all of this right here is actually the same thing as what's written down for argon. So what we do to shorten this up is we take this and we in brackets, not parentheses, we write Ar, because Ar is the noble gas that comes before calcium. And so then notice how all that stuff is there. This is what gets taken care of when we write that Ar. Now the only thing that doesn't get taken care of is the 4s2 that's right here. And so what we do is we write down 4s2 there in order to indicate that that's the shorthand configuration for calcium in the end. Now you might wonder, well, that looks like there's only 2 electrons there. It ends up, don't forget, there's 18 electrons hidden inside of the bracket, and then there's 2 more on the outside. So that's where we get the 20 electrons from in the end. So let's say that we wanted to write the shorthand configuration for cobalt. We actually looked at an example like cobalt before. So again, what we do is we look for the noble gas that comes before cobalt. Cobalt's number 27 on the periodic table, so 27 electrons. The noble gas that comes before it is argon again, so we write argon in brackets, and then we would go and we'd look, well, okay, after argon, since we would need to write down 4s2, and then we would go and say, well, okay, the next group is 3d, and since there are only 7 electrons that we would need to get to 27 in that point. Again, like I said, there's 18 in the argon, 2 in the s orbital, and then 7 in the d orbital. That's where we get the 27 from. And so this would be the shorthand electron configuration for cobalt. So just remember that you're writing a noble gas in brackets, and it can only be one of these 6 ones right here.